operations. So it's very emerging training, you can say, in the agriculture sector, apart from now latest things like AI and IoTs. So this is also one of the promoting topic uh, by the institution like Manage and KSTA in agriculture sector. So I hope this program is for the 3 days, and every day 4 sessions will be covered nicely. Framework has been prepared by the MSG. So all topics are quite interesting, and we see that some good knowledge will be given by the all excellent speakers identifying different institutions. Thank you, OSG. Thank you for giving us opportunity with the KSTA. So we'll continue this collaboration in future also. Thank you very much. Thank you, sir.
Thank you very much. Now I request our CEO, Dr. M. Ramesh sir, to give few words. Sir, you are not audible, sir. Sir, unmute ಮಾಡಿ.
Very good morning to all of you. At the outset, on behalf of KSTA, I welcome Dr. G. Bhaskar sir for this inaugural session. I welcome all of you to this 3-day webinar, applications of UAVs and drones for agriculture. I am thankful to Director General of Manage, Dr. Chandrasekhar sir, for providing us the opportunity to host this webinar. I also thank Dr. Bhaskar for coordinating with us in hosting this webinar. In fact, last year, we had organized a webinar on entrepreneurship development with the support of Manage, and it was also a good success. In fact, you were planning to host a offline program, physical meet. We had submitted a proposal to Manage, and I hope next time they will certainly support an offline program. KSTA had organized a 3-day national workshop on applications of UAV and drone during last December, and more than 100 participants were there. It was organized with the support of SCRB, and many people were asking us to host again the physical program, and I'm sure Manage will consider our request coming days. We'll be happy to host offline program. And in fact, for this webinar also, there is a good response. More than around 58 participants have joined on Cisco WebEx, and many more have joined on YouTube platform. Some would find it difficult to join on Cisco WebEx because of some complexities. Many have joined on YouTube. I welcome those who have joined on the YouTube platform also in this webinar. We are joined by Dr. Chandrakant Singhal, Head of Fisheries Research Station. Welcome to you, Doctor. And also I welcome my colleagues, Dr. Anand, Umesh, and Srinivas to this webinar. I'm sure it will help all the participants to broaden the horizon of their knowledge in this emerging field. In fact, in recent years, unmanned aerial vehicles and drone technologies have rapidly transformed the landscape of farming, offering innovative solutions to age-old challenges and driving efficiency, sustainability, and productivity to heights. As per a new report, the drone market in India is projected to go to $13 billion by 2030 from the present around $3 billion. So there is ample scope for drone and UAV technologies in India. In fact, there are remarkable ways in which UAVs and drones are revolutionizing agriculture. Among them, precision agriculture. People have been talking about precision agriculture since long, using satellite remote sensing because of fragmentation of our lands. It was difficult, but with the advent of UAS and drones, precision agriculture is now possibility, and crop management and monitoring could also be done by drones, by using your drones by farmers, progressive farmers. And yield estimation and forecasting is also quite possible with drones, with advanced image processing and machine learning algorithms, which can be used in UAS and can generate accurate yields estimates for different crop varieties and different field conditions. Mapping and land management is another area in which drones are helpful in creating topography, soil composition, drainage patterns, etc. It would be very easy to make maps out of this information. This information enables farmers to implement precision land management practices such as variable rate seeding, soil sampling, and soil erosion control. Apart from this, livestock monitoring could also be done using drone and UAVs. If drones are equipped with thermal imaging cameras and GPS tracking system, they can identify individual animals, detect signs of distress or disease, and assess pasture conditions. In fact, this allows farmers to optimize animal welfare and enhance grazing management and prevent losses due to predation or theft. According to an American consulting firm, agricultural drones usage in India will grow by 38.5% CAGR and reach up to 121, as I told, some $1 billion. Will be some $13 billion by 2030. Integration of UAVs and drones into agriculture represents a paradigm shift in how we cultivate the land and feed the world. By harnessing the power of aerial intelligence, farmers can make data-driven decisions, optimize resource allocation, and achieve sustainable growth in an ever-changing environment. As we embrace these transformative technologies, let us continue to innovate, collaborate, and strive towards a future where agriculture is not only productive and profitable, but also environmentally responsible and socially equitable. In this particular webinar, we will be having 12 distinguished talks by eminent scientists and technologists, right from basic drone rules by Dr. H. Chonnegoda sir, CEO Multiplex Drone Private Limited. Then basic principles of flight by Dr. Prithviraj, Associate Professor, Faculty at NITK. And he will also continue a talk on drone equipment maintenance as well. And in the evening, we will have cybersecurity for drones and UAVs by Dr. Uday Shankar Puranik. And tomorrow, we'll have applications of drones and UAV technologies in agriculture and agroforestry by Dr. Hebbar. He is the General Manager, RRC South. And the second talk will be on fixed wing operations and aerodynamics by Mr. Nagur Kani of Karnataka State Remote Sensing Application Center. Followed by that, ATC procedures and radio telephony will be delivered by Karthik H. He is the Assistant Professor in the Department of Civil Engineering at Presidency University. And the next talk will be on payloads, installation and utilization by Shri Mugilan Thiru Ramaswamy. He is viewers for Skylark drones. And next day, that's the third day, 14th Thursday, we will have a talk on drone computing and precision agriculture by Dr. S.N. Onkar, who is a renowned scientist. And after that, risk assessment analysis safety by Chintamani Pai. He is the adjunct faculty at Kumaraguru College, of Technology, Coimbatore. And post lunch post coffee session, we have a introduction to drone data and analysis by again Sri Mugilan Thiru Ramaswamy. And finally, post lunch, we will have one talk by Krushik UAC Solution, the CEO of this particular firm, will be speaking on drones and agriculture challenges with a case study. And by at 3:30, we'll be closing the program. I'm sure all of those who have joined will be highly benefited by this 3-day webinar. I once again am thankful to Manage for providing us this opportunity to host a webinar of importance, which gives information on emerging technology. In a few minutes, Dr. Honegoda sir will be joining and he will speak on basics of ATS, basics of drone rules 2021. Will be joining in a few minutes. That's all for now from me. I'm sure all of you will be benefited. I request all of you to join tomorrow also at right time to derive best benefit of this webinar. Thank you. Thank you.
Thank you very much, sir. I immensely thank Manage Assistant Director Dr. Bhaskar sir for providing continuous support throughout our this financial year and previous year also. We have collaboratively organized many programs, physical programs and online programs. Thank you very much, sir. Also, I would like to thank Manage all other supporting team and those who have joined with us today in this Dr. Chandrakant Lingadal sir and other staff from Manage and our KSTA staff, technical team, non-technical team. On behalf of all of us, I would like to thank you immensely. Thank you very much, sir. Also, I would like to mention here for accepting our invitation to deliver the talks. I would like to thank our Dr. Honegoda sir and Dr. Patyuraju Umesh and Dr. Udashankar Puranik sir, Dr. Ramchandra Hebbar sir, Mr. Nagur Kani, Mr. Karthik H, and Shri Thiru Mugilan Srinivas and Krishaka US Solutions Wing Commander Tom Sundarji for accepting our invitation. So formally we will end this inaugural session. Now we will wait for Dr. Honegoda sir. Yes, sir. He will be joining. He is joining now. We will start the session continuously. So meanwhile, those who have not registered and joined here continue in the session, please I request them to register and join WhatsApp group for any login issues or any other technical issues. And we have shared drone rules 2021 in that WhatsApp group. Hope all of you have received. And meanwhile, if you have any queries, please drop a message in the chat box, or you can raise your virtual hand so that we can unmute you and we can directly.
Okay, thank you.
Thank you, sir. Thank you, Bhaskar, sir.
Thank you.
Yes.
As I told, the first talk will be on basic drone rules 2021 by Dr. Honegoda sir, who is the former Secretary, Department of Science and Technology, Government of Karnataka. He will be speaking on international rules, regulations, standards, practices, civil aviation requirements, AIPS, NOTAM, and also classification and categorization of drones, type certification of drones, registrations, sales and deregistration of drones, operations of drones, and finally do's and don'ts, remote pilot certification and drone insurance. Sir will be covering all these aspects. Before we start, let me give a brief overview of his academic and academic career. Onegoda sir obtained his PhD in aquatic biology from College of Fisheries, University of Agricultural Sciences, Bangalore in 1989. He was a recipient of Junior Research Fellowship from Indian Council of Agriculture Research, New Delhi, for his PG studies, and he was awarded a gold medal for his PhD, after which he worked as a postdoctoral research fellow at the Department of Bioscience, Mangalore University during 89 to 90. Integrated coastal zone management from the University of Newcastle and the University of Bath, United Kingdom, and Anna University in 2000. He started his illustrious career as a research scholar at the College of Fisheries, Bangalore. After that, he was research associate at Mangalore University. Then he has also worked as scientist from scientist D to F at the renowned Research and Technology Institute, ISRO, Indian Space Research Organization. He worked there for more than 10 years. After he came to the state government as the director of Karnataka State Remote Sensing Application Center, Department of Information Technology, Biotechnology, Science and Technology, Government of Karnataka, and deputation from ISRO from July 2000. And he was also the executive secretary of Vision Group on Science and Technology, chaired by renowned scientist, distinguished scientist, Bharat Ratna Professor CNR Rao. He was director in charge of Science Gallery Bangalore, which was inaugurated recently. He was the managing director of Karnataka Science and Technology Promotion Society from 2012 to 2020 May. He was also the chief executive officer of Karnataka Science and Technology from September 2005 to March 2018. In fact, all the infrastructure that KSTA has today owes to his work and his initiative. Because of his initiative and vision, KSTA has got a good campus in GKVK campus. He was also the director, Department of Science and Technology from 2004 to 2013. Later, he was promoted as a special director from 2013 to 2019. In fact, he was also a special secretary, Department of Information Technology, Biotechnology, and Science and Technology for nearly 2 years. After superannuation, Dr. Onegoda sir worked as Dean Research at JSS Science and Technology University, Mysore, from for nearly a year. And during his tenure as State Remote as Director of State Remote Sensing Center, the center was developed as one of the most vibrant state remote sensing application centers in the country. And based on this, Government of Karnataka requested ISRO for his service to be absorbed as part of state government itself, way back in 2004. In fact, KSRSSE started a innovative MTech program in geoinformatics because of his initiative and vision in association with DTU and Survey of India. And even now the program is running well. Dr. Onegoda sir is responsible for establishment of regional science centers at Pilikula and Harvard. And he has also initiated many sub-regional science centers and more than 15 mini resource science centers and state-of-the-art dome planetariums. and he has published more than 50 research papers in both national and international of repute. He has been awarded with many national and international awards, including Citation for Excellence Award by College of Fisheries, Citation for Outstanding Contribution in the Field of Domain Expertise, conferred during the National Conference on Space Science and Technology for Geographic Research and Applications in 2005. He has also been awarded the coveted Kempegowda Award in 2007 by BBMP, Brihat Bangalore Municipal Corporation. He has also been a recipient of Best Scientist Award by Bharatiya Kannada Sangha in 2017. And with this brief introduction, I request Dr. Honnegowda sir to take over and deliver his talk. Over to you, sir. Once again, welcome to you, and please take over and deliver your talk. Over to you, sir.
Thank you very much for your kind words, Dr. Ramesh. Good morning, everybody. Are you able to see my PowerPoint presentation?
Okay, sir. Sir, first stop that sharing the screen, sir. Then you can share again once again that PowerPoint presentation.
Okay, okay.
No, sir. In the top there is a red stop. Yes, sir.
Yes, now you can see?
Yes, sir. Yes, sir. Perfect, sir.
Yeah.
Thank you, sir. Please.
I'll be presenting on little bit the basics about drone and the drone rules, which was formulated in 2021. So as Dr. Ramesh said, actually, currently I work as a CEO at the Multiplex Drone Private Limited. It's a leading agriculture drone manufacturer and service provider. We do a lot of work actually in the field of drone technology and its applications. We are mainly into the research and development, and also we provide drone as a service to apply the required and optimum level of nutrients and agrochemicals. We also provide the training program, particularly for the remote pilot training program. Now coming to the drone. Drone basically, is an aircraft. What is an aircraft? Aircraft is basically a plane. It's the actual vehicle and it's a mode of a transportation. Okay, and the flight actually describes about, Okay. A flight describes that you move from one place to another. In the broadest sense, the aircraft refers to all types of vehicles that fly within our Earth's sensible atmosphere. The common examples of aircraft include airplanes, helicopters, drones, airships, gliders, paramotors, and hot air balloons. All that actually come under the aircrafts. It's not only the aeroplane. Today, the aircrafts are divided into two categories, which are named as manned aircrafts and unmanned aircrafts. Coming to you are able to see my presentation, na?
Yes, sir. Yes, sir. Your video is turned off, sir. If you can turn on, that will be fine, sir.
Turn off?
Video, sir. Start
video. I have turned off actually.
Okay, sir. Okay.
1 minute. I'll do it.
Okay, sir. Please continue, sir. Thank you, sir.
Okay. Okay. Coming to the drones, they are basically a flying eye in the sky. And in fact, actually, as you are aware, the airplane and helicopters were mostly using the airspace, not many other aircrafts. And in fact, for the airplane and helicopters, there's a well-established and internationally accepted rules and regulations, particularly for the aviation. But in recent years, the introduction of drones in airspace has some important consequences for the shared use of the airspace, because the drones are seen as aircraft, although they are piloted from the distance. In fact, it's a remote pilotless. When you are flying a drone, in fact, we also become a user of the airspace. with its own rules and regulations. As a drone pilot, it is important for us to be aware of the basic drone rules. Otherwise, we will be interfering with the airplane and helicopters. Normally, when you're sitting in a plane, the pilot is responsible for steering the aeroplane. While in the drone, it is the person who is standing on the ground, he will be steering the drone in the airspace. Then what is drone? Drone is basically a oldest terms used to describe a pilotless aircraft. Basically, it is an acronym or abbreviation you can call, or you can call it as a slang term. It is usually referred as dynamic, remotely operated navigation equipment. An unmanned vehicle, which is basically a drone, is an aircraft without, as I said, a human pilot on board. Its flight is controlled either autonomously by computers which are there in the drone, or under the remote control of a pilot who is standing on the ground. In fact, the drone or the unmanned aerial vehicle is also being called by many names by various countries. In fact, it is called unmanned aerial system, a pilotless vehicle, flying mini robots, remotely piloted vehicle, remotely piloted aircraft, radio controlled vehicle, autonomous controlled vehicle, miniature pilotless aircraft, small unmanned aerial systems, remotely operated aircraft, remote piloted aerial application system. By in various names they call it actually in many countries, but basically it is very commonly said actually as the unmanned aerial systems, because it is not only the vehicle, it also carries the various kinds of payloads together, and also the various kinds of sensors together. It is called as unmanned aerial systems. In fact, if you look at actually the unmanned aerial system, there are different categories of unmanned aerial system. They are basically in India, we categorize them into three groups. One is actually the airplane, the second is the rotorcraft, and the third is actually hybrid unmanned aircraft system. In fact, all these three again are further classified into subcategories as remotely piloted aircraft systems, model remotely piloted aircraft system, and autonomous unmanned aircraft system. If you look at actually again further, it has been classified into broadly into five categories, based on mainly the size and also the flying height. The one is actually the nano drone, which is basically are very, very small, maybe less than 250 grams. These drones need not be registered. Otherwise, all drones have to be registered, like a car registration, it has to be done. Of course, I'll come to that later. No permit is required to fly except in the controlled airspace. Controlled airspace means actually near the aircraft, near the airport, or any strategic points, or which are very close to the airport, what we call actually the yellow zones. But only thing is that we should not fly above 50 feet from the ground level, or 15 meters from the ground level. With that, actually, the nano drone can be operated in any of the areas except in the controlled airspace and need not be registered. The second category is called the micro drone. Basically, they are something like 250 gram to less than or equal to 2 kg. Of course, for this, registration is required, and this micro drone can be flown up to 200 feet, not above the 60 meter or 200 feet. And no permit is required for recreational use, but permission is required for commercial uses and flights in controlled airspace. As I said, controlled airspace in near the airport and other strategic points. The third category is actually the small drone. which can vary anywhere between 2 kg and right up to 25 kg. But the maximum height it can be flown is only up to 400 feet or 120 meter. And registration is required 100%. There is no way. It's like a car license. It has to be, when you buy the drone, it has to be registered on a portal, which I'll come to that. And also it should be operated by a trained pilot who has got a license from the DGCA approved training centers. The fourth category is the medium drone, which can fly between, which can weigh between 25 kg to 150 kg maximum, including all the components. Not only the vehicle, even including the payload and what we call as the all of weight actually, that can be anywhere between 25 kg to 150 kg. And this also can go maximum 400 feet or 120 meter. And registration is required. DGCA approved pilots only can pilot these medium drones as well. And the fifth category is called the large drone. They are basically something like 150 kg or maximum 100 kgs. In fact, in the drone category, for a civilian applications, it is basically between maximum is actually the government of India has given the permission up to 500 kgs, and these can go up to maximum 400 feet or 120 meter height. Registration is required, and DGCA approved pilots only can pilot this large drone. Today, in fact, if you look at actually the maximum utilization in agriculture is basically the small drone and the medium drone. Basically anywhere between 2 kg to 25 kg and 25 to 150 kgs. And if you have a license for the small drone, you cannot operate medium drone. Even for that, actually, you need to have a separate license. Similarly, for the large drone also, we should have a separate license for that. I mean, these are the basic classification of the drones, depending on the maximum weight and altitude it can go. And basically, if you look at the drone, it has several components. It's a multidisciplinary kind of an approach. You require actually the mechanical engineer, computer engineers, and so on. And it will have actually the propellers. They are basically called as a propellers. You require a motor. You require actually the flight control system. This is most important. It is called brain of the computer, brain of the drone. Like it's a microprocessor basically. It's a computer. And it will have actually the first view camera, so that when it is flying, you can see the images. And also the electronic speed controller and power distribution board, because it is powered by either through a battery. And it will also have the various kinds of the software and firmware. So based on that, it can be autonomous, it could be a semi-autonomous, it could be operated by manually. And also there could be some kind of a sensors which can be built in the drone, which helps in avoiding any obstacles. When the drone is flying, if there are any obstacles, it can be avoided. That's called the obstacle avoidance. In the radar topography, that means depending on the height, the drone can adjust the height depending on the topography. Suppose in the hilly terrain, the topography is actually varying. The drone, if there is a radar topography, the drone can adjust the height based on the elevation. And it can carry any number of the various kinds of payloads. Like on satellite, you have a number of payloads. You have the visible payloads, cameras, multispectral cameras, hyperspectral, thermal, and also the light detection and ranging lidar kind of a thing. But not all of them, maybe one or two, depending on the type of applications. You can always carry, you can always inbuilt, you can add as a separate payload to the drone. You can attach it. And a transmitter will be on the ground. The remote pilot the one who has trained remote pilot will be operating the drone, whether it's autonomous or a semi-autonomous, or it could be a manually operated drone. For all that, actually, you require a trained pilot on the ground. So basically, when you look at the unmanned aerial systems, here, in fact, I try to call them as an unmanned aerial system rather than a drone, because actual term, the correct terminology is the unmanned aerial systems. So it has a 3 subsystems. The one is the aircraft itself, the drone. The second one is actually the ground system equipment, either a computer-based or a transmitter. Using a joystick, you can control the drone. And this control can be done by the pilot, remotely operated pilot. There is the human element. So these 3 components are the subsystem under the unmanned aerial systems. Now, if you look at the growth of drone technology, in fact, actually, the drone technology growth in India is happening from the last 4 to 5 years. After the drone rule was framed in 2021, a lot of startups have come up, a lot of developments have come up. Earlier, there was no proper rule for us actually to use the drone for various kinds of applications. Only when the drone rule was in 2021 was framed. Today, the drone is entering into many fields and is growing at a breakneck speed for varied societal applications. So along with this has triggered many advancements in the technology. A lot of startups are working on that. A lot of indigenous technologies are being developed in the last couple of years. As I said, it's mainly because today we have a favorable drone regulations. And the third most important is actually the restriction on import of drones. Today, if you look at, maybe a few years back until 2022, most of the drones were imported from China and other countries, mostly from the China. China has dominated in the field of drones globally, particularly the DJI drones, actually, we call them actually. They have been used extensively. Today, there is a restriction on import of drones. Only the components are allowed. Okay, so a lot of impetus are being given on the concept of promoting Make in India concept, to promote India as the most preferred global manufacturing destination, on the on the concept of self-reliant India. In fact, without self-reliance, we cannot assure sustainable development of technology. Importance is given for self-reliance in this field as well, and for which the government of India is giving a lot of incentives, both for the manufacturers as well as for the people who are using the drone for particular kind of applications, particularly in agriculture, which I'll come to that later. It is called production linked incentives. Now, for the manufacturers, it is given, particularly for the manufacturing and sale of drones, and also for purchase of the various drone components. And also subsidies are given for, particularly for the agriculture applications, particularly for agriculture graduates, for agriculture universities, KVKs, and also many central government ICR institutions. And even for the farmers, the loans are given. Even for the agricultural graduates, the subsidies are given, and also loans are given under subsidized interest rates. And then it's also because of drones today becoming cost effectiveness with over the years. Earlier it used to be something like 10 to 12 lakhs per drone. Today it has come to about 6 to 7 lakhs, depending on the kind of sensors it has on the drone. And also the number of applications, the drones. Today, in fact, actually, drones are being used actually in many of our human endeavors, which I will be covering in my next slides. and also the integration of modern technologies, particularly the artificial intelligence, machine learning, and deep learning are being used in many of the modern integration of these modern technologies in the drone. Many of the commercial drones to deliver enhanced required solution for the customers. If you look at the growth of drone industry, if you look at the global, actually, it is somewhere around 8.77 billion in 2022. And in 2023, it went up to 10.98 billion, almost 11 billion in 2023. And by 2030, they forecast that 54.81 billion. In fact, some of the other forecasts says actually somewhere around 77 billion. In fact, very recently there was one forecast. Now they revised it to about 150 billion. The use of drones globally. Of course, optimistically, I can always call it as 55.81 billion by 2020. This is the global scenario. In India also, the drones are being used, and applications with the government of India's and the state government supports. It's also going to increase in the coming years, and by 2026, they forecast somewhere actually about 120 to 150 billion rupees, not in terms of dollars. When it comes to dollars, it can be anywhere between 1.63 to 2.04 billion, maybe in another 2-3 years, with the support of the various finance schemes, as both for the manufacturers as well as for the users. In fact, agriculture alone, there is a trend that actually globally it may go up to even 7 to 10 billion by 2030-32. From the right now, from is about 1.1 billion. So it may expect to grow about 21.4%. In fact, the use of drone in agriculture perhaps is the second highest in any countries. In fact, today drones are extensively being used in South Korea, Japan, China, and many other countries. Now, if you look at today the types of unmanned aerial systems in the market, there are mainly 3 types. One is called actually quadcopters, depending on the number of rotors you have actually on the propellers and the motors you have actually on the drone. They're called, if there are 4 rotors, they're called quadcopters. They're slightly bigger, slightly smaller, and they can be used for the aerial photography and videography, and also for inspections and surveying. You can put, the camera, RGB camera, anywhere between 20 megapixel to 40 megapixels. Today in the drone market, you have 40 megapixel to 100 megapixels. In fact, this also can be used quite well for agriculture applications. But mostly the one which is being used for application of pesticides, the nutrients and other agrochemicals, they use mainly the hexacopter because it can carry more weight actually. So there's a hexacopter. It will have 6 rotors. There's basically 6 propellers, and it can go up to, it can carry about 25 to almost about 150 kgs. But most of the drones today, they are anywhere between 25 to some 35, 40 kgs, around that. Are octocopters. If there are 8, the propellers, the rotors, then it is called actually octocopters. When the payload is bigger, we can go for higher octocopters, so that stability will be better. But only problem is that the endurance time comes down. Like for example, the quadcopter can operate for about say 20 to 40 minutes, while these kind of a hexacopter or octocopter can, depending on the weight of the payload, it may work for about 20 to 30 minutes. One of the biggest limitations of all these, the drones, is basically the endurance. That means, it can work only, it can fly for about 20 to 30, or maximum in quadcopters about 40 minutes. But today, if you look at the global market, most of them, either the quadcopters, hexacopters, or octocopters, and mostly the for a crop spraying and the nutrient application of optimum level of nutrient is mainly done by using the hexacopter. The second type is called the fixed wing. The fixed wings actually can fly for a longer duration, but the weight of the payload will be less. In fact, actually, I have written here heavier payloads. No, basically they can carry about 800 grams to about 1 kg, but the endurance will be more. That means the flying, it can fly about, say, about 40 minutes, 50 minutes, and all that actually. And it is very good for agriculture, particularly if you want to really estimate the crop health and crop status. These fixed flying, fixed wing drones are very good, but the problem is that actually it requires the runway. While the quadcopters, hexacopters, and and octocopters, they can vertically take off and land, but these fixed wing, like aeroplane, it requires a runway. That is one of the limitations. Now, slowly the technology is being improved. The technology is being improved, and now they are getting into the what is called hybrid vertical takeoff and landing. Like this can take off vertically like a rotorcraft. Like actually I said quadcopter or hexacopter or octocopter, but it can, once it takes off and reaches the particular altitude, say 50 feet or 100 feet or 400 feet, maximum 400 feet, then it can fly like an aircraft. Now, while only for taking the, for takeoff, vertical takeoff, it uses the propeller and motors. Then while flying, it uses the fixed wing. Okay. So they are actually being developed, but still actually they are in the experimental stage. In fact, they can also carry a slightly higher payloads, maybe up to 5 kg it can carry, of course, depending on the type of the technology which they are developing. Today, they are developing various kinds of payloads and also the capacity. In fact, today the biggest limitation is the motor. In fact, today motors, they can come for about 20 minutes to maximum 40 minutes. I think if there is an improvement in that, it will be wonderful. And some people are also going for the battery as well as gasoline, so that it can fly for a longer period. Now, if you look at the application of drones today, it is being used in many applications. You can see actually in agriculture, environment and wildlife monitoring, rural and urban development, forest mapping, search and rescue, surveillance and monitoring, mapping, land surveying, traffic monitoring and law enforcement, disaster management and relief, asset protection, delivery services, firefighting, photography and videography, medical emergency transportation, basically for medicine actually, inspection and maintenance, reconnaissance, and many other geospatial applications. In fact, I must say, touching almost every aspect of the human endeavor, both in terms of natural resources mapping, environment, disaster related thing, and so on. Coming to agriculture, now whatever the kind of payloads which you use on the satellites, the similar kinds of payloads could also be used on the drone, except very poor resolution sensors like passive microwave sensors. Other than that, we can always use whatever the cameras or sensors are being used on the satellite can also be used actually on these drones. And like RGB camera, blue, green, and red, it works mainly in the 3 visible spectral bands. can provide you very high spatial resolution. A few resolution, it can provide you, even you can count the number of trees. It's as good as actually looking from your own eyes. And you can always fly, anywhere between a few meters right up to 100 meters, 120 meters maximum. You can also use the multispectral. It will have 5 to maybe 4 or 5 spectral bands, particularly for assessment of the crop health. The multispectral camera will be very, very good actually, because it can provide you the spectral information in the red, the green, near infrared, so that you can always use different indices for assessing the crop of the health. And we can also go for the thermal one. Thermal basically even to differentiate the kind of the animals entering into the farm, based on temperature differences. Of course, it's slightly expensive compared to other cameras. It can also be used for irrigation and water management, disease mapping, based on the spectral reflectance. And the other two important ones, they are in the developing stage. One is the hyperspectral imaging sensor. It's not just 5 spectral band. It's a continuous spectral bands from 400 micrometer right up to 2400 micrometer, nanometer actually. 400 nanometer to about 2400, 0.4 to 2.5 micrometer. It is very good for the plant health assessment, even to identify the species. It can be done, and water quality assessment can be done, and also the various vegetation index like normalized vegetation index, green index, and so on. And the full spectral sensing can be done. It can have actually about 30 spectral bands, 100 spectral bands, even 200 spectral bands, depending on the type of hyperspectral imaging sensor you have. And the most important one is the LiDAR. In fact, some people call it as a LiDAR, light detection and ranging sensor. This is one of the very costly sensors. It's still actually being used only in a few particular applications, particularly when you want to map the terrain, 3D digital, even the urban area. In fact, of course, you can also map the height of the crop. Of course, since it's very costly, you need not to use for that, but I just mentioned that actually. So the flood mapping, and it could be used very well, but still it's in the experimental stage. It requires a lot of expertise. The spatial analyst is actually, maybe one should have a trained spatial analyst, and he should use a lot of algorithms actually for development of this, deriving the information of spatial information. Like, for example, the drone could be used very well for cross spraying. It's one of the biggest applications today we have is for the cross spraying. Our multiplex drone, we have a rich experience in spraying, using the drone for spraying various crops. In fact, we have done the spraying on 56 crops actually, both field crops, horticulture crops, plantation crops, and so on. A typical drone image looks like that. In fact, I've taken many of the images from only for purpose of this presentation and only for the learning purpose. I have downloaded from the internet the various the drone images. In fact, this is the image actually which is being used for even property identification and to give a property ID card. There's a major program going on in Government of India, Swamitva program. Under that, actually, they want to map all the 6.62 lakh villages and give the especially the property, for providing the property ID, and also for taking of various developmental works for a proper planning and geospatial applications. See, you can see the actual. You can even stretch the image. It's only one shot actually taken. Actually, this can be enlarged to a few mm. depending on the type of camera we use actually. Even the health of the crop could be assessed even by looking at these vegetations. One can able to look at, even you can map a few centimeter topography of the land. Very precise. Flood mapping and even thermal image. I said actually animals entering into your farm can be identified even during in the night actually, based on the temperature differences. And in fact, one of the biggest applications for using drone is actually basically when you use the multispectral cameras, you can able to identify the status of the crop health based on the reflection which comes from. You're aware that in agriculture, the plant looks green because it reflects the green. Okay. While in the diseased one, the reflection in the green comes down. That means that actually is a stressed one. And near infrared is another way of looking at actually in the healthy plant, the reflection is very high in the near infrared, while in the diseased one, the reflection is very less. That's why when you stand under a diseased tree, you feel too much of heat. It is because it doesn't reflect much of the near infrared. It penetrates. So based on this, that's the reason actually we should, to understand the health of the crop, we need to have minimum 4 to 5 spectral band, particularly in the green, red, near infrared, and blue regions. So there are several indices are available. One of the common indices which has been, many of them are using is called NDVI, Normal Differential Vegetation Index, which is basically near infrared minus red divided by near infrared plus red. It gives you the health of the crop. If it is, if it is nearer to the 1.5 and above, it's a good vegetation, healthy vegetation. If it is less than 0.5, either it's a stressed vegetation or a mature vegetation. See, you can see actually, the red one indicates is some stressed vegetation, while the green indicates it's a healthy vegetation. It's based on deriving the normal vegetation index. So the other important actually I was mentioning is the LiDAR, light detection and ranging. Actually, it is called LiDAR. Of course, it's in the development. The sensor is very expensive, and it's still challenging. A lot of issues should be overcome. Of course, now it is being used on a small scale by very renowned experts in the field. Of course, drones could be, as I said, for many applications, including transportations. But one of the biggest applications today is in the field of agriculture. And since you are all related to agriculture, I will restrict my presentation mainly to the agriculture. The advantage and disadvantage of using drones, if you look at, the advantages are it's a cheap and cost effective. It provides high spatial resolution in terms of a few millimeter. It provides you very high accuracy. Because it provides you high accuracy, today they are going to they'll be issuing the property ID card, particularly in the rural areas. Because in urban areas, most of the urban areas, they have the property ID. While in the rural areas, in the villages, there is no property ID. That's the reason actually they are using this. In fact, it is because it's a high accuracy, easier to deploy, and can fly multiple times in a day. You are controlling the drone. You can, fly the drone at different times. It's very precision, ease, and flexibility, and not much hindrance from clouds. In fact, if there is a thick clouds or if there is high wind, yes, drone also cannot be operated. But if there is not much of wind speed and not much of clouds, it can be operated. While in the satellite data, you get whiteness, but not here actually. Okay. a great tool for surveillance. You can map the entire agriculture crops of Karnataka using several drones, since it can be launched at different places simultaneously. And also the various softwares can be developed which can avoid some of the sensitive and non flying areas, the controlled areas like airport or any strategic points. If you develop any, what this is called as a geofencing to prevent drones from flying in sensitive areas based on the software you have developed actually in the flight control system. Of course, we also have a few disadvantages. Basically, one is most disadvantage is that today the drone cannot be operated except the nano by anybody. It should be a skilled drone operator, and he should be informed about the drone regulations, which I'll come to that later. And he should know the regulations quite well, and should be the cost, of course, still it needs to be optimized. The government is giving a lot of subsidies, but if there are no subsidies, but still the farmers feel the pinch of this, so the cost needs to be optimized. And as I said, some extent weather dependent. If it is highly rainy, windy, and highly cloudy, it's difficult to operate the drone. It's better not to operate the drone. As I said, one of the important applications of the drone today is in the Swamitva program, and they have plans to survey about 6.62 lakh villages of the country. It was initiated in 2020, and it could be used for various planning purposes. Once if you get the images from this, it could be used for multidisciplinary purpose. It could be used by agriculture scientists for watershed mapping, or it could be used for any other purpose. Finding out the exact the lake area and so on, and through which the property card are going to be given, and this will be supplemented with the very good ground control points. Of course, that is also most important actually. So most of this, now coming to the regulation, after we learned something about the drones, we should also know about the rules and regulations for flying the drones. That's most important. This is really required for the safe and responsible flying. In fact, these rules are being framed by Director General of Civil Aviation, which functions under the Ministry of Civil Aviation, Government of India in New Delhi. The Director of General of Civil Aviation is our overall regulatory body for safety and airworthiness of, for issuing the license for operating the drone, and also what type of drone to be flown. All that actually are being issued by the DGCA. We call it as a type certification. And in fact, DGCA is responsible for the overall regulation of air transport services within India, as well as actually, for the enforcement of civil air regulations, air safety and airworthiness standards. And also it coordinates regulatory functions with many international civil aviation organizations. And its headquarters is located in Delhi, as I said, and regional offices in various parts of India. The drone rules was published on 25th August 2021, and that's why it is called as a Drone Rules 2021. Until this, the use of drone was very, very difficult. Only after these Drone Rules 2021, now we know where to fly, where not to fly. Until then, there was no proper guidance for us actually to use the drones. These rules shall apply to any person who is owning or possessing the drone, or even you take on a lease, or operating, or transforming, or maintaining an unmanned aerial system. All these drone rules 2021 applies, and these drones aircraft should be registered in India. In fact, there is a separate portal for this, like what we do the car registration. Similar to that, the drones to be registered, and the DGCA portal is called digital sky portal, and all unmanned systems that are being operated for the time being in and over India has to be invariably registered except the nano drones. And today, as on today, the drone can be maximum, as per the notification, the maximum weight, all of weight actually, we call it actually, is only up to maximum 500 kilograms. That also include air taxis, but most of our drones today are, say, 80 to 90% are between the category of anywhere between 225 or 25 to 150 kg, small and the medium. Of course, the bigger ones still actually the rules are not well defined for getting the type certification. Maybe with time, actually, it will be done. Hope so. Of course, these rules doesn't apply to any government, central government organizations like actually naval or military or air forces of our Union India. All drones, as I said, except the nano category, must be registered, and nano drone cannot be operated beyond 50 feet. And micro drone can be flown below 200 feet, but if it is for but registration is a must, but you don't have to have a license if it is for recreational purpose, if it is for R&D purpose. But if it is for commercial purpose, only the licensed drone operator should operate these drones. The pilot must always maintain a direct visual line of sight. That means when drone is flying, you should be able to see through your eyes. Drones cannot be flown more than 400 feet vertically, and drones cannot be flown in areas specified as no-fly zone. Like, for example, near airport, I said, near international borders, 25 kilometers around the international borders, civilians should not fly the drones. Vijay Chowk in Delhi or any state secretariat complex, strategic locations like ISRO, DRDO, on these places, and any military installations, the drones should not be flown. Of course, even in urban areas, it should be flown with the permission of the authority, because drones still, they might crash and fall on the people. That's why the drone should be, before flying the drones in urban areas, you need to inform the concerned authorities and make an announcement that the drones will be flown in the areas. In fact, there are some areas that, temporary no-fly zones. Like you would have heard when Prime Minister came to Bangalore a few days back, they said 24 hours drone is not allowed to fly in those particular areas. They are actually temporary zones, no-fly zones. So we need to follow these because of a strategically important aspects like security-related things. So permission to fly in uncontrolled controlled airspace, we cannot normally fly, but only with the permission. Filing a flight plan, and the reason for that, we need to take the air defense clearance or flight information number. From them, actually, we need to take the clearances. Then only it is allowed. Now, in fact, actually, the entire India has been classified into 3 groups. One is called the red zone. The second one is called the yellow zone. The third one is called the green zone. The red zone means the airport near to the airport. 5 kilometers in and around the airport, one cannot fly the drone without the required permission. That is called the red zone. The yellow zone, again, 5 kilometers from the red zone up to 8 kilometers, it is called the inner yellow zone, where again, no drones allowed to fly. Huh? Yeah, please. If you have any question, you can ask me.
No, sir, please continue, sir. That was uninterrupted.
Okay. Then the second one is called the, from 8 kilometer to 12 kilometer within the yellow zone itself, it is called the outer zone. Here actually up to 200 feet, is not allowed. Beyond 200 feet with the permission it's allowed. Then the next one, beyond 12 kilometers from this actually, is called the green zone, where you can fly without any permission. In fact, 90% of the India covers under the green zone. That's why now today we have a large airspace for flying the drone in the green zone. And many of our agriculture areas are falls under the green zone. That's why we have a large airspace for use of the drone, particularly for the agriculture applications. So in a summary, I can say the green zone, airspace up to vertical distance of 450, that is not designated as a red or yellow zone. Even in the green zone, you cannot go more than 400 feet. If you are going more than 400 feet, you need to take the permission from the government of India. And most of the drones, either the small or medium classes, are normally, the DGCA gives permission to fly up to 50, 200. Their capacity is also actually something like 50, 100 feet or meters, actually. Maximum 120 meters. Okay. Then the yellow zone, airspace above 400 feet in green zone. Here also actually 400 feet and above is not allowed, and airspace about 200 feet within the outer yellow zone, that is 8 to 12 kilometers from an airport. These are restricted and need the air traffic control authorities permission. Of course, red zone not at all allowed. Okay. I think the same thing. As I said, the drones can be operated with the permission from the red zone, but a lot of regulations are there. You have to follow that with some particular purpose, And the geo zones, temporary zones, as I said, actually, if there are any events are going on, if there are the VVIPs are coming, they temporarily declare these are the areas drones should not be flown. They are called geo zones actually. And this, in fact, actually, I said actually the digital sky for the entire country, whatever the drones are there, whatever actually the green zone, the different zones, and whoever the pilots are all being actually, they registered in that digital sky. Just if you click the digital sky .dgca, you will get all kinds of information from that. Okay. It's a very, very interactive map. That is the sky, and demonstrates the entire zones actually which are demarcated. Not only the red, yellow, green zone, even the geo zones, that's the temporary zones. So anyone planning to operate a drone should mandatorily check before they use the airspace, so that they will get an about whether it's a temporarily or permanent the no flying zones. In fact, this is how actually it looks actually. If you just click it, actually you can enlarge it and you can see which are those red zone and yellow zones and all that actually. Like, for example, this is a of course, maybe you can go through that website, Digital Sky, and see actually. I think mine is the Digital Sky. So in fact, there are, when the drone rules have been notified, there are 12 parts in that actually. Each one of them explains in detail about what type of drone, the classification of the drone, where to fly, where not to fly, what kind of a license to be obtained, where we can obtain those licenses actually. All the details can, and how do we get registered actually in the Digital Sky. All the details have been given in this drone rule 2021. In fact, a copy of that I have mailed to the KSTA. They might circulate that actually, this drone rule 2021. Please go through that carefully, because I'm not going to cover the entire thing. It is more of a monotonous. Okay, I only taken out some of the important aspects and trying to explain to you. Dr. Umesh,
Yes, sir.
Sir,
how many minutes more I have?
you have 15
Sir, you can take 10 more minutes, sir. 10 more minutes.
10 more minutes.
Yes,
Okay.
sir.
Even the testing of drones.
Yes,
In
sir.
fact, the drones actually, whatever the drones we fly, it has to be approved by a particular class of the drone has to be approved by the DGCA. It's called type certification. Only those type certified drones should be used for flying. Otherwise, it is they will take action by the DGCA will take action on us. Okay, even if there is an accident of a drone, it has to be reported to the digital sky within 48 hours. And even for obtaining a remote pilot certificate, you will have to obtain a certificate from an organization which has been recognized by the DGCA. In fact, ours, Multiplex Drone Private Limited, is one of the approved DGCA certification training center. Only in those centers you can get the pilot training. Only thing is, it's about 5 days training, 5 to 6 days training program. A set of syllabus have been defined by the DGCA. Only thing is, people who want to become a pilot, want to get a license for pilot, they should have passed 10th standard, and the age should be 18 years and above and less than 65 years. And they should provide all the identity cards like Aadhaar card, PAN card, passport. Now the passport they have removed actually, but still on the Digital Sky platform, it asks for the passport. But now the Digital Sky platform, there's slightly there in a days to come, they are going to move to some other platform which will be announced by the DGCA, and also the health certificate also should be given. And this pilot license is valid for 10 years. After 10 years, again, we'll have to renew it. Once if you pass the exam, actually in the this 5 days, 6 days training program, you have to get 75% marks. Then the concerned training center upload your information on the Digital Sky. Within 8 to 10 days, you will get the pilot license. In case if you deviate from anything of this, and if you are violating that, actually, they will put a fine. Even for the remote training organization, also they will put a fine subject to maximum of 1 lakh rupees. Okay, Digital Sky, you can see actually this is the website. You can go to that website. Otherwise it takes time for me to open and see. And also, many of them actually, I already said actually, they don't have a software. In fact, this is not a mandatory right now actually, but it is going to be developed in the coming days. No permission, no takeoff. Okay, the drone itself actually in the flight control, where I said actually it's a microprocessor, a mini computer, where a software we need to be uploaded, so that without a permission is permission on the Digital Sky. Okay, the drone itself will not take off, and the drone, like a car, should have a identification number. It is called unique identification number, UN number. A particular number is given and is shown on the Digital Sky. And operator permit actually, as I said, is required. Permission is required, and the Digital Sky platform, and also ensure that drone is in a good condition, because the drone actually, before flying, we should see any damages are there. Drone is also a puzzle. Basically, the propellers, the battery endurance is only about 20 minutes if it is using a big payload actually, or maximum you can carry up to 30 liters, 40 liters. Today the drones have been developed even to carry 50 liters. Okay, and there should not be many interference basically from mobile devices or even electrical lines. Actually, sometimes it may cause some obstacles actually, and drone might crash actually. Ensure that actually slightly away from all of that actually, and as far as possible, fly mainly during the daytime, after sunrise and before sunset. Fly in a good weather condition. As I said, wind speed should be slightly less and not too cloudy, and fly in a visible line of sight so that you can see where the drone is going. Follow all guidelines which are given by the DGCA, mainly for the safetiness. So before purchase of the drones for agriculture application, we should understand all these rules, and we should also undergo the training invariably. Also understand the restriction of airspace, respect it actually, and always stay away from airports and heliports. Respect the privacy of people, because you cannot fly on somebody's land without their permission. It's better to inform the people around the surrounding the area where you are planning to fly. Keep local police informed about your flying activity. Okay, this all I've explained to you already. Don't fly the drone over government facilities without a permission, or military bases, or any strategic locations. And don't fly in controlled airspace. Don't drop or carry hazardous material. Don't fly a drone under the influence of drugs or alcohol. Don't fly the drone from moving vehicles, ship or aircraft. So these are the broader rules actually the government of India has framed by the DGCA. Please go through that. There are 12 parts in that. Each one of them, like how to register the drone, what type of certification you should get from the DGCA, all that are being given. No doubt, still the drones are in the infancy stage in our country. I think in the coming years, we hope to have a mass adoption and usage in the country, because a lot of government departments, particularly the Ministry of Agriculture and Farmers Welfare, Ministry of Fertilizers, Ministry of Rural Development, and also by the respective state governments are giving much importance, and many of them have started their own policy. The states are also have started their own drone policies in order to promote the use of drone. The subsidies are also Government of India is providing through the state governments. And today the drones, as I said earlier, it has been used for many applications, and a lot of new applications are coming up. A lot of technological innovations are also happening, and at the same time, a lot of newer applications are also coming up based on the technological innovations. In fact, the Government of India has forecasted that India is going to be the world third largest drone market by 2025, and the Government of India is planning to make India as a global drone hub by 2030. By concluding, I can say actually, UAS, the unmanned aerial systems, like in tomorrow, it may be used like what we are using, like computers and mobiles in the years to come. And the Honorable Prime Minister looks at that. Actually, it should be, the drone should be by 2030 or so to be flown on every farm for pesticide applications, nutrient applications, or assessing the crop, and so on. So naturally, the growth of drones in the future are going to be a wonderful in terms of development of new technologies. A lot of disrupted technologies are coming up, and particularly with the use of artificial intelligence and machine learning, like even variable kind of a cross spraying of pesticides or nutrient depending on the requirement. And there is a cost effectiveness for a commercial applications of drones, and new drone technologies are coming up, and more cheaper is becoming actually, and entire drone ecosystem are being developed actually today between the manufacturers, suppliers, service providers, and rapidly emerging within this system. And the government is also adapting the drones, as I said, around the globe. They are giving a lot of importance for this. Even our own government is giving a lot of importance for adoption of drones. That's why a lot of subsidy schemes, a lot of promotional activities are being taken up, and the government regulation of drones are also being slowly favoring for operating the drones, particularly in the green zone. Basically ensure in order to promote the safe and responsible users. With this, actually, I would like to thank Dr. Ramesh and all the KSTA staff for giving me this opportunity, and also to the participants. If you have any questions, please feel free to ask me. Thank you very much.
Thank you very much, sir. Sir, there are two questions. What are the other applications that are used for image captured from the drones for the calculation of NDVI apart from R software and Python software, sir?
Can you repeat it?
Any other softwares that are used for the NDVI calculation data
Yeah,
captured from the
there are many softwares are available today.
Yes, sir.
You know, the Fix4D is the one actually which is extensively being used, and you know, many our own software S3, the drone software is available. Agisoft actually it is called. There is another software is available. Drone deploy software is available. Many softwares are available. In fact, actually, it is going to be India, right? Maybe right now there's a good opportunity for development of many of these softwares for drones, data analysis, and drone data, you know, extraction of information almost in near real time.
Thank you very much, sir. So any other questions, please let me know in the chat box, or you can raise your virtual hand. And a few of you have asked the zone calculation, how to find out the region under red, yellow, and green safe zone for flying of the drones. That link we have shared in the chat box, Digital Sky, dgca.gov.in. From that website link, you can check.
Yes, yes.
The zone is.
Yes, yes. You can check all the, you know, permanent the areas which are under the green, as well as you know, yellow, inner and outer yellow, as well as the red zone, and also the temporary zones. In fact, there's one thing which I mentioned also actually, before flying the drone, we should check actually on the digital sky whether any temporary zones have been earmarked. But they are there only for 48 hours, the temporary zones. Maximum actually about 98 hours or so, maximum 4 days.
Thank you, sir. Sir, what are the different permissions from authorities, police or DCs, etc. needed? Please advise.
What are they?
Different permissions from the authorities required, like police, DC needed. Please advise.
See, for in the green zone, okay, if you are operating less than 400 feet in the green zone, only thing is your neighbor should know actually if there is any restriction, because when you are, you know, spraying the pesticide, you should not go and fall in the another owner's land. You have to inform. Suppose if you are flying in the urban areas, you have to inform the concerned authorities, the police, like BBMP actually, for example, in Bangalore, BBMP you have to inform. Then we have to inform the police. You have to inform the DGC also actually that you are going to fly. And the digital sky, everything actually on the airspace is available. Digitally, you know, and the digital airspace is available actually. You can inform them actually.
Thank you, sir. Thank you, sir.
Thank you very much for a very scholarly talk on basics of drone rules 2021. In fact, right from the basics, you gave a good overview of different rules governing drones and UAVs. On behalf of KSTA and all the participants, we are immensely thankful to you. In spite of your busy schedule, you could make time to deliver this distinguished talk. Thank you very much.
Thank you, Dr. Ramesh, Dr. Umesh, and
Thank
all
you, sir.
the
Thank you very much, sir.
KSTA staff and also the participants. Thank you so much.
Thank you, sir. Thank you, sir. We have shared that basic drone rules document to all the participants, sir, already.
Very good, very good.
Yes, sir. Thank you, sir.
Thank you.
Thank you, sir. Thank you. So we'll be having now the next session from Dr. Prithviraju Umesh, who is Associate Professor, Faculty, Researcher and Technology Integrator from NIT Surathkal. We'll wait for him to join. He's trying to log in. Wait for 2 minutes and then continue for the session. After that, we'll be taking for the break for lunch, and post lunch we'll be having 2 more sessions followed by Dr. Prithviraj sir and Uday Shankar Puranik sir. Meanwhile, if you have any queries, please mention in the chat box, and those who have not registered and not joined the WhatsApp group, request them to join the WhatsApp group also. Please provide your feedback also. Before starting the session, I would like to give a brief introduction about Dr. Prithviraj Umesh sir. Currently working as an associate professor in the National Institute of Technology, Karnataka, Surathkal. He is a faculty, researcher, as well as technology integrator. His key achievements are he has done more than 35 numbers of R&D projects, budget grant of 38.54 crores, and he has published more than 69 journal papers of reputed national and international papers, and he has done consultancy projects more than 64 numbers with a budget grant of 5.9 crores. And his research interests include wave structure interactions, open source product development, wildlife conservation, and autonomous navigation system, advanced surveying and GIS applications. With this brief introduction, I would like to welcome Dr. Prithviraj Umesh sir. Sir has a vast experience in the field regarding aerial photography. He will be sharing his own experiences, what are the challenges that he has come across in his endeavors. Waiting for him to join. Stay with us. Presentations cannot be shared. Those who are requesting, they can please go and watch in the YouTube link. The presentations are not shared. since they are confidential and some rules are there not to share the presentation. Please, you can go to the YouTube and watch and rewatch the sessions. I welcome Prithviraj sir once again, who is with us now. I have already given introduction. Welcome, sir. On behalf of Manage and on behalf of KSTA, I welcome you to deliver the session, sir.
Yeah.
What to use? I have given an introduction already, sir. Thank you.
Yeah, fine. I thought it's 12:30, no session?
Yes, sir. Yes, sir. But the session, since it's online, we have reduced that cut.
Okay, fine.
Thank you, sir.
Manish, are you there? So actually, my 3 staffs will be sharing, and
Okay.
they'll also be coming live to showcase.
Fine, sir. Fine.
Okay. Manish, are you there?
If I need to anybody in the panelist, please let me know, sir.
Yeah,
So that
yeah,
they'll-
yeah. I'll.
Yes, Manish, I have given you the privileges, please. Manish, you can unmute yourself.
Okay. Thank you, sir. Sir, am I audible?
Yes, audible.
Yeah, Manish, I'll start with search, and we can showcase it live. So let me start my presentation. Let me share the screen once.
Okay, sir. Okay.
Vishwas, I will give you the permission. Just a minute.
Vishwas, anyone else? Aishwarya Hegde has to be given.
Yes, Vishwas, please check now.
Hello, sir.
Yes, please. Manish and Vishwas, you have all the privileges to share and yes.
Yeah. You are able to see the screen, what I'm sharing?
Yes, sir.
Yeah.
Yes, sir.
Okay. Yes. So, good afternoon to all of you. I'm Prithviraj, faculty in the Department of Water Resource and Ocean Engineering from NIT Surathkal. What we successfully we are able to solve some of the societal problems. It can be elephant tracking or it can be for agriculture applications, and how it is been used successfully. Now, here if you can see on the screen, there are 3 images. So one shows a regular RGB image, another one shows a multispectral image, and the next one is a thermal image. How these different payloads are being effectively being used for solving some of the societal problems, and how students over here. So as we are from Education Institute, how students are using it to solve the problems that comes to them is being showcased. So let me start and think how a drone-based mapping, a tool for decision making by using RGB, thermal, multispectral, and LIDAR applications. So now, the image what you can see here is basically called search. Search stands for System for Emergency Assistance Response and a Communication Hub. Over here, you can see it's an NITK campus. It's inside campus. It is a portable containers are being used. to achieve and meet the targets. There are solar panels which act as one of the source for the entire running this system. And there is a small black and white circular thing, yellow and black circular, which we call it as Aruka code, and a helipad where the drone will scan that and land. And there is multiple antennas over there which are used for communication for VHF, HF, HF. And there's a 3 mode of power source, either from the electricity board, there's a diesel generator, and there's a solar. For basic amenities, there is solar power, which is of 5 kilowatt. So what this project search? So this was the entire infrastructure that was built by using the contributions from the alumni, and the students and staffs have put their hands to build the systems or integrate the systems that can solve societal problems. So what societal problems can be? Either monitoring coastal erosions, monitoring the health of the mangrove plantations, or maybe water quality, air quality monitoring, or use this as a command center for search and rescue, or communication when disaster strikes, or maybe preparedness, or increasing people in awareness regarding ham communication and making the systems to work. So you can see over here, there are few salient points like autonomous aerial vehicles, unmanned marine systems, command centers which are being used, wherein which we can command or communicate across the world, or maybe interstellar will be able to communicate, including a communication device that can, or we can reflect communication onto the moon surface and get back the signals, or and the entire thing is on a portable cabin, so that this system can be transferred from one location and shifted onto another. So let me showcase a small video on how the system works before we proceed further. Let me share that screen onto the tab. Is the voice audible?
Yes, sir, audible.
So here what you saw was how this system is. Basically, you have a weather station. Weather station will help us to make an automatic drone launch. Suppose if it's too windy, it will avoid the drone to take off. And this was the earlier system, slightly how before all the solar panels was placed. So these are the antennas which will show you live before it is been placed. And this is X beam, and you have a spider beam also. There's a communication setup. You can see the flight and the fleet monitoring system that is there. These are the amplifiers and the radios which are used for communication. We have an e-mobility system designed and developed by students, which will showcase how they integrate during disaster. The autonomous marine vessel, simple by using bodyboard, how it has been converted into measurement of bathymetry setups. And there are drones which are used for heavy payload systems. And here you have a point and shoot camera, you have the DSLR cameras or a surveying grade cameras, along with you have the lidar systems, then heavy payload drones, and of course this off the shelf surveying equipments. So this was how the system is used, and here you can see how the helicopter can land onto the systems, autonomous helicopters. Here you can see the autonomous marine autonomous helicopters in collaboration with the few firms that we have used and successfully and trying to operate. And it lands on the system. This is an electric marine system which we have used, and now simple kayak which we get on Decathlon has been made into autonomous for water quality, bathymetry and other studies. You can see it's electrically driven. You have a GPS system, RTK system, and you can see one of our staff, Manish, will showcase the search, wherein which he is basically using VHF to communicate, and the remotely monitored systems. So this is how the system works, the charging setup. So you can see over here the antenna setups. It is 55 feet height, 85 feet height, 45 feet at different setups. So you can see a different view over here and how the system works. And this is the view which will showcase you live. So the first container which shows you on all how the communication with the drone or on the marine vessel that can be done. And in the middle for the maintenance of those, so it's called as dry dock. And the last one is for recharge. The recharge is for the operators, recharge is for the drones. When it lands, it docks, and then the recharge of those system happens. So this is the top view of it, the current top view of it. You can find the first one, which is at higher elevation. So this is the communication. You have the solar panels, which will help us to pump 5 kilowatt of energy onto the system, and you have an Aruka port where the drone will scan and land. And next to it, you have the beach, and this is how the communication hub is, including Morse code communication can also be activated and being used. So the other is you'll be able to monitor the fleet, you'll be able to monitor the flight, you will be able to launch a drone by using a small ground control stations. You can change the payload. Sometimes we use off-the-shelf ready-made drones to use it, or sometimes build our own and use the system. So here you can see the thermal inspections that is going on for New Mangalore port or other systems. So this is a typical example of fleet. And this is how the drone, you can see over here, there's an helicopter which is remotely operated or autonomous, which comes and lands onto the system. And then there's a multi-quad rotor. This is a GIS application that we do and use it. And finally, so you can see how this entire system works and how we are able to do it. So what I'll do is I will stop sharing this. Manish, you can share the command line and showcase the actual setup. Manish?
Yes, sir, he is there.
Yeah.
Manish, can you able to share now? Did you get the privileges?
Hello, Manish.
Sir, he is connected.
Okay. Anyway, in the meanwhile, till he comes online,
Okay.
so let me showcase on how other systems want, what are the topics that we will cover and how we will go one by one.
Manish, I
Hello,
have
sir.
given
Can
all
you
the
give
privileges.
permission for Manish for video sharing? So he's asking for it.
Yeah, I have given all the permissions, sir. You can share.
Oh, okay.
From the smartphone or from any other external camera you are sharing? Manish?
He is using mostly smartphone.
Okay, sir. Then I need to give Manish yes to present. Please check Manish. I have given privileges to Manish yes now.
Hello.
Yeah, Manish.
Yes, Manish.
Yes, sir. Yeah. Is this video visible?
Yeah, yeah.
Yes,
visible.
yes, visible.
So what Manish is showing is basically a setup inside the container one, which is a communication hub. So you can see there is next to it there's a beach, and it is our command center, where in which we will be able to launch a drone or autonomous marine vessels or multiple drones, or monitor the drones or the flights that are flying in and around that area, the fleets that are flying in and around, all the disaster related communication independent on Airtel or GSM networks by using HF, VHF, listen to the air traffic controller setup, what they're communicating by using this. So you can see how the flights have been communicating with the ATC, and all these entire setup is connected to multiple cameras. And what Manish is showing is a portable ground control station for an drone, from where we'll be able to launch. It is customized, built by using a simple suitcase, and there's a touch screen, there's a power bank, and there's a small CPU which runs for it inside the suitcase, which can be tapered, and there are USB ports which are used for communicating or acting external antennas if required for increasing the range. So the next to it, there is one, SDRs connected onto the radios, which can be used for communication. And this is what it shows onto the screen. Manish, can you showcase any flight or fleet? Yeah. So zoom on. Yeah. So how many flights that are there, and is on the right hand side if any flights are coming. So you can see over here the fleets that are there. So there's an antenna which is outside it. So you'll be able to see which fleet, which oil tanker, or whether it's a fishing vessel, or is there any other vessel, from which port it is coming, where it is going, what is the status, is it the engine on condition, whether it's anchored, all those informations right from our stations can be, and it will be connected onto the cloud.
Sir, should I go to the next
Yeah.
container?
Yeah, you can showcase from outside how the container looks.
Okay.
So from here, basically what you are seeing is a communication hub. We have slightly elevated it because of the compound wall. We will not get the permission to break over it. So we elevated it so that we'll be on the side, and you can see over here the entire communication setup that is there. And there are multiple antennas. There is a wind socks that is there, which shows the wind direction. There's a weather station which is connected onto it. So based on the wind speed, wind directions, it will actually guide and automate itself for the drone launch or in any marine setup that is there, which will be able to take care. So on the other side, you'll be able to find a dish which is directly communicating onto the satellite. So it is for use for exclusive for communication. It looks similar to an Airtel or an Tata Telecom dish that we put it for an household network, but the direction is completely different. It is towards the west side. It is looking towards the Middle East, and on the behind you will have very high end antennas, Yagi antennas at a height of 90 feet. The truss is around 85 feet, and you have antennas of 60 feet length which are there, which have been erected. So there are four, as of now, three such towers at 85 feet, 88 feet, 45 feet, and around 55 feet. And from there, around 10 feet to 9 feet is a variation. And you can showcase the dry dock. Did you show? Yeah. Yeah, this is a dry dock where the maintenance of these autonomous system happens, over which there are solar panels, and you can find the yeah. Manish, can you yeah
Yes, sir.
lens? Can you just clean? So it's for me. It is just looking. Yeah. Yes. Yeah. So you can see this, which will showcase now. It's called as SARO. How autonomous system is used for maybe siltation in a lake or a river. How it can be done. Then you have bigger boats, bigger kayaks. You have e-mobility system. There you can show the bikes and which is used for disaster management. Yeah. And the vertical profiler, which is used for navigation and water quality measurements in the rivers or behind the lakes, and it is being connected by a neutrally buoyant cables, wherein which it will help us to communicate onto the ground station. And there is also a wireless unit wherein which using we'll be able to communicate. Manish, you can show the last recharge from outside. Yeah. So this is actually recharge hub, wherein which on the top the drone lands, and inside there is a communication, recharge unit, wherein which the battery and other units get charged automatically. And there is a facility to recharge also for the operators. So there's a small cafeteria, uh, and a restroom and a toilet that is required for them to get refreshed. So when this system will be completely operational 24/7, its entire container can be portable, can be carried away to different units or if locations. So we have added one more. Manish, you can come out and show container 5. Manish, you can. There may be a network weak in the container 4. So you can come out and show container 5. So what you can find over there is how an actual container that is used for doing the setups of any autonomous systems of any purpose. Maybe assume that they need to be a survey. This entire container can be taken away, and it can be used for monitoring it. So this is the towers. You can show container 5. There's an canoe which can be going through sea, so which is under alteration. So we are currently making it completely autonomous, which will go on to the seas of thing. And there's an outdoor display unit. You can go on to, yeah, this is a container 5, the diesel generator, the container 5. And next to it, there is a communication tower, which is at around 55 feet. Yeah. So from here, we'll be able to communicate across the world, immaterial of any other communication. Yeah, Manish, thank you, Manish.
Okay, sir. Okay.
Yeah. So now, why all these concepts was required? We wanted to showcase how this system can be used for fabrication and then operating it and getting the things done. So let me proceed further with the screen that showcases on Vishwas. Are you ready?
Yes, sir.
Yeah. So let me share the screen on the topic. So you can see over here, basically we will try to touch on the topics that are there on how we can build a drone and use it, make in India, try to use it in applications, make our students to build, get involved in practical problems and solve it. Then agriculture applications, so elevating intelligence. It can be thermal, it can be multispectral, it can be hyperspectral, or take forward by using precision surveying and use it for LIDAR. It can be surveying of anything. It can be topology, it can be topography, it can be for highway surveying, it can be for forest surveying by using high precision LIDAR equipments. Or finally, print everything and then convert that into a physical model by using 3D printing. So you can see in the last slide, that is on the left side. So there's a 3D printed model. So now Vishwas will show that model, how we have 3D printed by using our HP 3D printer. So there is no colorization in it. Vishwas, yeah, you can show that model. Slightly up, you can lift. Yeah.
Is it visible?
Yes.
See my
This is a completely 3D printed model. I can see on our slide what we have showed and what he is holding. Is on campus of IIT Jammu, where in which a regular drone survey used to be done, and one deliver was this. So you can show the reverse side how a powder is being solidified, and yeah, it's gray color, yeah, and how on the topmost layer we are able to print the true color. So HP Jet Fusion 580 is the model, and we are able to print it. Now here you can see the solar panels. Will be able to see different features, including JCB, the buildings and other infrastructure that is there on it. Yeah, thank you, Vishwas. So this is the screen that you can find over here. The entire what Vishwas has shown and what is actuals over here. So there's a drone image. Then from those multiple images, it is been taken and then processed it. And from there, we are actually trying to showcase it onto the post-processing, use it for survey, and then proceed further. And there are multiple setups which we use it. In the meanwhile, before we proceed further, let me showcase one of the uh, video how precision surveying is helping us to proceed further. Share the screen.
Ancient text quote, Jalam Jivhayati Jagat, meaning water is life. Water being such an elixir of life, its preservation and replenishment becomes our utmost priority. Our government of Karnataka has taken a step closer towards water conservation and eradicating water scarcity and has initiated a project Paschima Vahini for constructing series of small-scaled vented dams along the length of the west-flowing rivers in the Western Ghats. Numerous surveys were conducted at the dam site using the latest technologies at Center for System Design and Water Resource and Ocean Engineering Department of NITK, Suratkal, in collaboration with Minor Irrigation and Groundwater Development Division, with the aim of assessing and quantifying the scientific and economical benefits of the vented dams constructed by the Paschima Vahini project. Resistivity survey was conducted at suitable locations to collect the underground features of soil, such as type of soil present, aquifer properties, etc., to analyze the degree of groundwater recharge due to the construction of these dams. To acquire the data of the total volume of water stored, as well as to obtain the details of underwater ground surface, bathymetry survey was conducted. LIDAR survey was carried out at the dam site to collect the details of all features above the surface of Earth. This will create a complete virtual 3D model, which can be used to take any kind of measurement such as volume estimation, area coverage, etc. of the dam site. Virtual reality was also employed in this 3D model. Photogrammetry survey was also done to create a photorealistic virtual walkthrough with 360-degree view of the site. To get the ground coordinates, differential GPS was employed at the dam site. To assess the quality of fresh water, water quality analysis was carried out, and various water quality parameters were studied in detail. Google Earth Engine tools were also used to analyze various parameters such as land use, land cover, variation in temperature, and vegetation cover. Feedback forms were prepared with some basic questionnaires and were distributed among the villagers to know about their experience after the dam construction. These dams not only have scientific benefits but also help in the economic growth of villages near the dam site. The construction of a vented dam not only stores water, but is also accompanied by many other benefits such as improvement in water quality, spread of greenery due to groundwater recharge, no land submergence. The dam can also help in joining the shores of the river and be a means of communication. The conduction of these surveys will give us a better understanding of the soil-water relationships and will help us to take a huge leap in efficiently planning future water conservation programs. These data can be used to propose future sites for vented dam construction under the Paschima Vahini project, thus ensuring efficient use of funds as well as highest benefits to the people around.
What you saw here was how we are integrating drone surveys into one of the actual case study that we got. So what you can see was there are 700 dams, canals, minor vented dams, and lakes and other things. So what we had got was to do the survey across all these dam sites. It is not only drone, but also to do the resistivity survey, use DGPS, use precision surveying using LIDAR, which will showcase you now, and how we integrate it. Autonomous systems, what you saw now, like marine vessels, where in which bathymetry, depth, all those measurements can be done, so that we will be able to do a scientific study and then try to get an output on how these systems are helping and how these are functional and what is the delta increment in increase in groundwater levels, and how an project monitoring can be done by using virtual reality and using precision lidar surveys. So this is a typical example. How an aerial 360 degree, so this is an 360 degree photo of a dam site, which the executive engineer used to see, because we used to update the data onto the web server, and through their mobile they'll be able to monitor it, and then on in situ water quality measurement, or getting the water sample onto the site, onto the environment lab, and then doing it, and the integration of Google Earth Engine, the regular questionnaires asking the local people the pros and cons and all those information. So this is how here you saw drones, the advanced surveying techniques that was used to cater the needs and solve some of these problems. So now Vishwas will show you some of the drones that we have there over there and how we proceed further onto the analysis. Yeah, you can activate your voice, Manish. Sorry, Vishwas. Yeah.
Am I audible, sir?
Yes, yes, yes.
So what I'm showing now is this is an indoor drone, mainly for research purpose in indoor areas. So while so drones are drones, machines, when we are doing research or something, not we may not be sure that it will work as we intended. So for the safety of the human as well as the safety of the drone itself, we have made a cage as well as the drone. So in this case, the drone has a cage and this normal thing. So when it flies, in case if something goes wrong, so nobody will be hurt, even the drone will be safe, so that we can reuse it, reprogram it, and do further testing. So mainly it can be used for indoor mapping or AI/ML, like autonomous detection, all those things. And all. This is one of the drone, and I'll showcase one more drone. I
Yeah.
think it's visible, right?
Yeah.
So
Right. So this was the drone actually, which is also used in search project, wherein which it scans and lands. It has an RTK system also embedded. There's a gimbal wherein which it does the photography mission. The cameras can be chained to the desired required payload. Either it can be used for air quality, it can be used for multispectral, it can be used for thermal imaging. The interchangeable. Of course, it's an payload carrying capacity is less. It's an hexacopter, so you can rotate it. To showcase hexacopter. Yeah. So there are 6 rotors. So if it is 4, it's quad rotor. If it is 6, it is hexacopter. 8, there's an octocopter. So there's an lithium polymer battery which is being used, and an open source technology is being used to design and fly. So these and all are integrated, and some of the things are built and in used by the students group. And the next version of this is basically used for agriculture farming. Manish, who showcased it, had presented a paper in USA through our alumni, Professor Devdas Shetty. So that work basically showcases that whenever there is an pig or any other creature in a pineapple farm or any other farmland, so the system gets activated and then the system flies. Uh, uh, Vishwas, can you show tetracam? Can you show
yes,
the
sir.
tetracam model? And how that system can be used and how the system works. So basically what happens, there will be a sensor in the farmland property. So it detects the creatures or animals coming during the night time. It detects the motion. It communicates using LoRaWAN. It communicates back, and then it signals the drone. The drone flies onto the location, loiters it, and we'll show you that technical paper out of it. So what Vishwas is holding is an tetracam multispectral system from it's an USA device, and there is also the other one. What he showed now was the earlier was a DJI, which is an off-the-shelf product. So this tetracam can be integrated with any drones that you build and fly, or else if you want to use an off-the-shelf system, you can actually go with DJI or any other brands which are available, which are permitted to fly within India. So what we usually do is we take some standard drones which are off the shelf, and for students and who are doing research, we actually make them to build. So there's an engineering group which builds. There is an PhD group which will analyze the data sets and then process further and then use it. So let me showcase how precision survey is being done before we move forward onto the advanced hyperspectral. Yeah, let me share the screen.
The wise consider time is money, and LiDAR survey does just this, providing large and highly accurate data within a short period of time, which otherwise will take a huge amount of time or even when the area is inaccessible. So what is LiDAR? Light detection and ranging. LiDAR is a remote sensing method used to examine the surface of Earth. In this case, the device is mounted over an unmanned aerial vehicle to collect the data of the required area. Using the ground control station, the waypoints has to fly. Monitoring of all the required sensors, drone health, ongoing flight
I'll
and
just one day.
GPS GNSS connection is done with the GCS. LiDAR and photogrammetry devices are merged together so as to get highly accurate and precise data. The images captured through photogrammetry.
Sir, request to share once again that video, sir.
Yeah, I'll share it. Is this screen visible?
Yes, sir.
Yeah.
The wise consider time is money, and LiDAR survey does just this, providing large and highly accurate data within a short period of time, which otherwise will take a huge amount of time or even when the area is inaccessible. So what is LiDAR? Light detection and ranging. LiDAR is a remote sensing method used to examine the surface of Earth. In this case, the device is mounted over an unmanned aerial vehicle to collect the data of the required area. Using the ground control station. The waypoints are created over which the drone has to fly. Monitoring of all the required sensors, drone health, ongoing flight progress, and GPS/GNSS connection is done with the GCS. LiDAR and photogrammetry devices are merged together so as to get highly accurate and precise data. The images captured through photogrammetry are stitched together, analyzed, and the processed data is merged with the LiDAR data so as to get a highly accurate data set with RGB colors. From this we can get the orthomosaic map, DTM, DSM elevation model from which we can obtain detailed measurements of any point in the area such as cutting and filling, area calculations, volume estimation, etc. And this data can also be used for creating 3D mapping and printing. Differential GPS was used for the geo-referencing of the whole project for centimeter level accuracy of flight planning. Experts suggest LiDAR will be the basic building block for all future systems and the future is here.
So what you saw was how LiDAR is. So afternoon session will showcase you the live demos of these systems, and visuals will be guiding us through the data processing and other things. So I'm just brushing through how these drones, GCS, the existing Trimble photogrammetric processors have been used, and then we process the data set. Wherein which we will also showcase how a drive LiDAR, how an aerial LiDAR, and an terrestrial LiDAR can be integrated to get into precision surveying. It can be for agriculture, it can be for an building management or a topography or an industrial area. So all these, so that maybe an mega infrastructures like that can be used for dam sites or it can be any other projects on hydroelectricity or thermal plant or any kind of survey wherein which precision surveying is required for the railway track studies. So live case studies that can be used and that can be processed it. So now what we will showcase is the channel called Center for System Design. You can browse to that channel. Let me showcase that one. Channel name is Center for System Design. Let me share the screen. Yeah. Is the YouTube channel visible?
Yes, sir.
Yeah, yeah. So this is the channel wherein which some of our project sites, all those have been uploaded. The center called Center for System Design, wherein which transdisciplinary project runs. So what you saw now, all those works are basically not by one faculty, not by one student. Professor Gangadharan heads the center, who is currently the Dean Planning and Development, along with who is also a mechanical department professor. Here you can find most of our projects that are ongoing that has been showcased. It can be precision survey, it can be e-mobility, it can be drone related, it can be charging stations, or maybe related to the virtual labs, V-labs, or the document tutorials that we do. All those are typical examples of how these systems have been used, and we are trying to. So what we will showcase now is a small documentary on a small process where students from different disciplines had maybe around 5 years back. This document is a 3-year-old. There are a lot of advancement that has happened, which Aishwarya will showcase to you. So let me share this video. Is this video visible?
Yes, sir.
The Department of Water Resource and Ocean Engineering, in coordination with the Center for System Design, begins a journey to bring elevating intelligence using drones to address farmers' woes. Though agricultural decisions are subjective in nature, use of technology can indeed help quantify human intervention, allowing right and timely mediation to gain profitability. And profitability is what would sustain this industry, despite the vagaries of nature and manpower which can overwhelm this industry. The department offered a novel practical case study in conjunction with a theory course. The next step was to proceed to study a farm with its own set of challenges like diminishing soil health and failures in drip irrigation system causing crop distress. Being unfamiliar with the intricacies of farming, a select team of staff and students proceed on a journey to get a first-hand interactive field study to gather details of farming. This is highly essential because every individual grower would have their own sets of problems, and so whatever products or solutions may finally be arrived at by using technology should be beneficially reaching the target population. This study, however, does not claim to tide over all other previous farming solutions, but is a definite one step to farming profitability. The staff and students of NITK gets a taste of the farmland and map the area under study. Once a clarity is reached on what information could be most beneficial to the grower, they set forth with the multispectral camera machine learning tools to take the raw aerial footage using a drone. The data then is allowed to immediately run through a software for processing and arrive at a base layer of the information. Multiple imagery at different times, that is during the growth of the plants and seasonal changes, provides further data for analytical processing. Using this technology, the actual number of plants, their individual health and nutrition levels, and also an in-depth analysis of the weeds could be gathered, thus providing the grower with loads of beneficial information which was otherwise not possible in the past.
So what you saw here was basically a group of students using, I'll just forward all this, how their application happens, and
the grower was highly impressed and profusely thankful of the efforts and dedication by the students and the staffs of NITK in providing him with vital information about his farming sector, and was more than enthusiastic to pass on the message to his own brethren. The Government of India, led by Prime Minister Sri Narendra Modi, have been proactively participating to introduce the breadwinners of our country to use technology at every level, like smart farming, which has definitely shown better yield. This has been one of the many such initiatives within NITK, where a department plans to introduce its students to real-time problem-solving methods using their theoretical knowledge, while the technological support like drones are provided by the Center for System Design. Over the years, many such partnerships have yielded appreciations for being beneficial to both our students as well as local populations.
So what we saw over here is a typical example of how an multispectral images have been taken, and the normalized vegetation index has been created. And of course, this is a small case study that is been projected. Now Aishwarya will showcase how this entire system is done for different area, compare it with satellite data sets, and how it can be also helping for the insurance agencies, which provides and helps the farmers in a large scale. Of course, what he showcases is a very small land, but how it can be used for an bigger area also. Aishwarya, can you showcase a small case study on anyway? Yeah.
Sure, sir. I hope my voice is audible.
Yeah, yes.
Yeah.
I hope my screen is visible as well.
Yes.
So, as Vishwas had shown the drone, this is the DJI P4 drone with multispectral cameras. So, if you see here, the camera has 6 sensors. So, each sensors will capture a specific wavelength, which will help us to monitor the agricultural fields. So, since you know the visible range is between 400 to 700 nanometer, this particular sensors will capture even the near infrared regions. So, when we see here, the detailed demo is shown here. So the first camera will capture the red edge band, that is between 730 nanometer, 700 to 730 nanometer. So this is like a small range of wavelength after the visible region. Similarly, the second camera will capture the near infrared region, that is above 840 nanometer, then followed by green, then blue and red, and there is one camera that will capture the visible, that is the RGB images. So if you see here, in the near infrared region, the reflectance of the vegetation is very high. So the information of the vegetation is captured highest in the near infrared region, whereas in the visible region, because of the presence of chlorophyll band, the reflectance is very less. Similarly, beyond the near infrared region, that is in this region, the reflectance will be again very less due to the presence of water absorption band. So that is why this multispectral camera, since it captures the near infrared regions, it is most suitable for monitoring the nature of the vegetations, and hence it is now being used in agriculture domain. So if you compare the vegetation, the reflectance curve of different land surfaces, this is for vegetation, this is for soil. So that is, here we can clearly understand that in the near infrared region, there is maximum reflectance for vegetation. And for water surfaces, the reflectance is very low compared to the other land surfaces. So I will show you, okay, next thing is about the vegetation indices that can be extracted from the data that is captured from the multispectral data. So as I said, there are 6 cameras, and from the information captured from each of these sensors, we can calculate few of the vegetation indices, which is for us useful to measure the greenness or the chlorophyll content in the plants. So the main and the most common index that is used is NDVI. So it is calculated using this formula, that is near infrared minus red by near infrared plus red. So similarly, we can calculate one more index, that is NDRA, using which uses the red edge index. Other than these 2 indices, there is one more index that you can calculate, that is GNDVI. So here, if you see, this is the red edge image, and if this is the near infrared image, we'll apply this formula, and for each pixel we'll calculate the NDVI value. NDVI value will vary from -1 to +1. So -1, and the negative points will be mostly the non-green surfaces, that is not, which is like urban surface or soil or barren land, whereas the positive values, that is above 0, whatever values are there, that will be the green surface, that is the vegetation. So I'll just show you the NDVI data. I hope the screen is visible.
Yes, it is visible.
So this is the data that is captured from the multispectral image. So if you see in this scene, there is a barren land, then there are some plantations here, and then here there is some built up area. And if you observe this field, there it is in the initial phase of groundnut growth. So there are small saplings. So here, this particular multispectral data will have 5 bands in it. So each of the band will be information collected from the each of the sensors. So from this we can calculate the near infrared NDRE, that NDVI, that is normalized differential vegetation index. So as I said, it is the formula for that is near infrared minus red by near infrared plus red. So if you go to the calculator, you can see the 5 bands are there. So using these bands, we can calculate, and the NDVI image can be created. So this is the NDVI of this particular region. So here you can see the tree tops are having the highest NDVI value, that is in positive. So that will indicate a high greenness. So similarly, like how we calculated the NDVI. So here each pixel will have one value. So if you see here, so the NDVI value at this point is 0.5, whereas here if you go near the rooftop, it is minus 0.4. So NDVI will show the property of the surface. So other than NDVI, we can calculate normalized differential red edge index. So that particular index is used for calculating the amount of chlorophyll that is present in the plant. So that is most useful in crops that have very dense canopy, and it will help us to estimate the amount of chlorophyll present in the plants. Similarly, there is one more index called as GNDVI, that is green NDVI. So it will indicate the water and nitrogen intake in the crop. So that will also have pixelated value, and the value will vary from -1 to 1. So based on the crop that you're using and based on the application, you can extract these vegetation index and monitor the crops. So the applications of the multispectral images is mainly to identify the pest and weeds in the crop, so that pesticides can be used appropriately, and it can be also used in optimized way. And once we detect where the pesticides are there and the treatment is given, it will help us to get the prevent the disease from spreading and before the crop growth. Also, the multispectral images can detect nutrient deficiency and hence can give information about the soil fertility. Using these multispectral data, we can use it for land management, that is to decide whether the agriculture land can be utilized and or either there is some crop rotation that needs to be needed. So it will also, using these multispectral data, we can count the number of trees or any plantation. So these are few of the applications of the multispectral data. So the processing of the data is done using softwares like Pix4D, Drone Deploy. So all the images are stitched to form an orthomosaic data, and then the indices are calculated.
Aishwarya?
Yes, so
Yeah.
that's it from my side.
Yeah. So now what we will do is we will showcase. You would have seen how a 3D printing, how a data is been done and it been processed, and then we were able to get a 3D printing map out of it. All those things. So how the data is pushed onto the cloud? Either you create your own open source system by using um, WebODM or any other method, or use a third-party softwares like Drone Deploy or an DJI Terra softwares. It can be any other. So now there are multiple ways. Whether if you want to have your own server, the best way is to, one of the best way is to install in your own server a software called WebODM. Now, Vishwas will showcase how a small data sets can be used and then uploaded onto server by using any technique. Either nowadays we can just, if you have an internet, you really don't require any PC also. Directly the data can be pushed through a mobile onto the cloud and initiate the processing part of it. Vishwas, can you share the screen of Drone Deploy and proceed further? Show it as a live demo.
Sir, is it visible, my screen?
Yeah. Drone Deploy is, yeah, correct. Yeah.
Okay.
Visible.
So this is the drone deploy account. So what we are trying to do is now photogrammetry, trying to do measurements from images. So these images are actually taken from drones. So I'll showcase the images. It's visible, right? So please give me.
Yes, visible. Yes, visible.
So these are aerial images, and if you observe properly, these images are kept an overlap of around 70 to 80%, a side overlap. Similarly, there is a front overlap of 70%. So when there is some overlap, so we can do something called triangulation. So same point is visible from different camera locations. So these locations will help to get the exact pinpoint the location of those images. So these software will do it for us. So I'll just simply show, like this is called dronedeploy.com. So you can actually Google it and you can create an account. I'll create a new project. So here you can, if you want to fly, you can give by its coordinates. Right now, what I'll try to do is I'll try to upload the data. So you can just click on upload the data. So by creating a new project, I'll ask for choose files. So we'll go for this is a classwork I have seen. So this has 68 images. I'll select all the images and
So
I'll drag
visible.
and drop to the cloud.
Vishwas? Okay.
Sir.
Yeah. Some of the some things got missed. Okay, no issue.
It
Selecting those images was not coming.
Okay, so like
Okay, no issue.
I have
Proceed.
done a shift select, and just you can drag and drop, or you can just copy, or else you can one more method is you can actually select choose files here, and you can select which images is required. So if require 10 images or 100 images, we can just select all those things. So I'll select from these. This is from a region in NITK, so captured by ourselves, somewhere near the swimming pool and tennis court area. Now it will show all the details. So if I click view details, so these are the image locations. So we can see how image is arranged in a grid pattern. So there is some overlap between each images as well as in like side overlap as well as front overlap. So once this is done, right now for this demonstration, we are not adding GCPs. We can also add ground control points, a checkered marks, as well as along with the its measured coordinates using differential GPS. So once the image is uploaded, like selected, so we can create an create project, and we can give a name as testing or any other based on our project. And we can actually select which zone we are in. So this is in South India, we are actually in 43N zone. So if it is north, it will be 44N. Based on the UTM zone, we can actually select here, and we can click on start upload. Now this will upload the images, and the cloud processing is done by the company. So they will after like depends on the image. So it may be a 30 image, it may take like half an hour or something. And if there is more than 100 or 500 images, So it will take 1 or 2 hours. So this trial version is limited to 3000 images. So we can actually try it out. So once the processing is done, we can actually see how the data is there and how to use the data. I think that will showcase after the lunch break.
Yeah.
So you can actually.
Yeah.
So
Thank you.
here the. Hello, sir.
No, proceed.
So here actually you can see how much of the upload has been completed. So until the upload is completed, do not close this window because upload will be closed in midway. So only half of the data will be there. So once upload completed, you can close the window and you can open it in another computer or somewhere else also. So they can actually monitor because this is in the cloud, not in the computer itself.
So now there are many other competitors for this softwares also, but there's Don't Reply, there's Pix4D, there's standalone softwares, or else you can build things from scratch. Now JS softwares also are integrating into this processing. Or if you want to have every data at your own place, of course, then what happens is you have to invest heavily on the machines. When suppose there's a huge area, entire city has to be mapped, then you require a very high-end machines that you have to, or a workstations in which you can have the software. All this also is taken away by the web services, something like what Don't Reply or any other softwares which are competitors. Wherein which the processing cost, we have to just pay a monthly thing. We just need to have a laptop or an iPad and or any tablet wherein which data can be directly pushed and then we do. So WebODM is one which students are using it, our students which are using it. We install it on our workstations. Any data that is there, it remains with us rather than going on to the cloud. And is it open source? So lot of tweaking can be made, and it can be performed. And many features can be integrated onto it before as being open source and helping students to innovate on their coding techniques. Sir, can we, are we ending it, giving a lunch break and starting after 2:30?
Yes, sir. Yes, sir.
Yeah.
Around 2:40 we can start. Sir.
Yeah.
1 hour break.
Okay.
Thank you very much, sir.
Okay. Thank you.
On behalf of KSTA and on behalf of Manage and all the participants, I would like to thank Dr. Prithviraj sir and his team, Aishwarya Hegde, Manish and Vishwas. Thank you, sir.
Yeah,
Such
thank you.
great effort to showcase many years and many months struggle and the service and R&D and consultancy services you are doing at NITK. It's great to see, and it's indeed an immense pleasure those who are witnessing this session online in this YouTube channel as well as WebEx platform. Thank you. Now we will have a health lunch break. After 2:40 we will join here.
Yeah.
Thank you.
Thank you.
Thank you, sir.